My name is Matthew Koenig, and these are my teammates, Omar, Amakat, and Dennis in the middle. Our project was to develop a brace mouse that addresses the problems that carpal tunnel syndrome may impose. Carpal tunnel syndrome is an inflammation of the wrist, tendons, and muscles. It causes a compression around the wrist. It can be very painful. It affects 1 in 20 Americans, and OSHA rates it as the #1 occupational hazard in the office environment. So our solution was to attach a system of accelerometers and gyroscopes to a CTS brace to communicate linear and angular acceleration data wirelessly to a computer, which allow a user to control the mouse functionality seamlessly. So we used a text instrument sensor kit to serially communicate gyroscopic and accelerometer data. Then we used that data to measure the acceleration due to gravity. And it looks a lot like a helicopter's throttle. When you're censored, it doesn't move at all. But as you move left and right past a certain threshold, it can start accelerating in different directions. This device works in 8 different directions with 3 different speeds possible. And there's 3 modes of operation. With the flick of the wrist, you can click when you're in click mode. If you're accessing a document or something, you can enter scroll mode, which allows you to scroll very seamlessly. And finally, there's a click and drag mode, where if you're in this mode, you can drag, highlight things, and select multiple things at once. We designed several test parameters for the system. I guess there's 2 real metrics for how well this system works. A is sort of a medical standpoint. Does it actually alleviate symptoms for carpal tunnel syndrome? A lot harder to test as a group of engineers. Debbie was actually responsible for contacting several medical doctors, but of course consultation costs are so high, we didn't get any conclusive results for its medical efficacy. As for performance as a mouse, we developed 2 tests. One was a drawing test. We tried to draw the same rectangle 3 times in a row, and we compared the trackpad versus our product, and the results were very comparable. If not, ours was more accurate at drawing spots. Second test was a clicking method. Can you click inside of these boxes, and how long does it take to do it? Our solution took a lot, maybe 3 times as long as using a conventional trackpad, and we did have 2 errors, as opposed to the perfection that the trackpad was able to produce. So overall, our system is very cheap to implement wireless mouse for people with carpal tunnel syndrome. That mirrors mouse functionality fairly well. I guess just offhand, not being a medical doctor at all, I think it does actually alleviate some of the tension on the wrist, but because you have to hold your hand and manipulate it like this, it might actually cause some shoulder problems. So, as you will, it's medical efficacy, like I said. To summarize who did what for this project, I was mostly working on the hardware and the design perspective for the form factor of the mouse. Omar did all of our programming on the computer end, making sure that we could look at these thresholds and set it up so that it worked efficiently and quickly. Debbie Lola, like I said, was in charge of contacting medical people and also developing our test metrics. And Amaha did our communications interface. Happy to take any questions you might have.
It only took 32 seconds to click those boxes.
Well, that's actually probably a little bit better. If you try to use this mouse using the sort of the acceleration system, it's a little bit jittery. So there's probably a little bit more optimization that could go into the code to try to parse out that information a little bit better. And you're welcome to come to our display booth and try these tests. We have these tests pulled up on the monitor. You can put on the brace and try it for yourself. There is some optimization that needs to be done, of course.
What was the greatest challenge the team had to struggle with?
That would definitely be the